Clean architecture, as its name suggests, aims to make the structure clean, organized, and easy to maintain. In this episode, we'll explain it in a simple and easy-to-follow way. Formally, it's a way of organizing your code so that it becomes easy to understand, modify, test, and scale over time.
The core idea is to organize the code into layers, where each layer knows only about the layer inside it or the inner one, but has no knowledge of the layers outside it. The layers and their names in clean architecture are actually the same ones we discussed in the previous episode about design patterns, so I highly recommend watching that one first, as it will clarify many of the differences between these patterns. Let's start explaining the layers from the inside to out. The first one is the domain layer or core logic layer. It's the foundation of the entire architecture and doesn't depend on anything else to exist. It contains entities, the fundamental data structures of the app, such as user accounts or product information.
The other part of the first layer is use cases. These represent the operations or actions that the application performs, such as logging in, purchasing a product, rating a service, or executing any specific process. The second layer is the data layer. It is responsible for fetching data from APIs or storing and retrieving it from a local database. This layer contains repositories, which handle all interactions with the data sources and databases. Just like in the MVVM pattern, each entity usually has its own repository to manage its data operations.
The third layer is the presentation layer or UI layer. It interacts with the use cases and displays the data to the user. This layer is responsible for everything related to the user interface. It contains view models, activities, fragments, and composables. Clean architecture is not mandatory, but it becomes highly beneficial in medium to large-scale applications. Additionally, many companies list it as one of the key requirements for developer positions, so it's important to be familiar with it.
Before showing the code example, I should first introduce you to the owner of the application. Meet Ms. Jane, the owner of a modern clothing store who wants to showcase her amazing products through a mobile application to reach a larger audience of customers. Therefore, we'll start by developing a simple example that demonstrates how to fetch and display data on the screen using clean architecture. First, let's create a product class that contains the product ID, name, price, and its image, and add the entity annotation to make the class represent a table in the database.
Next, we need an interface to define the use cases at a basic level. A simple explanation of an interface. It's merely a declaration of certain operations without specifying how they are implemented. For example, you can declare an interface with two functions, one for producing sound and another for eating food. Then, when you define a class that implements this interface, you must provide the actual implementations of both functions. Each function here represents the declaration of a single use case, such as inserting a product, getting all products, or getting one product by its ID.
Now, to write and execute individual use cases, we first define the interface outside the use case class. Then, we receive it within the use case function, and execute only the function that corresponds to that specific use case. The purpose of using invoke is to make it easier to call an instance of the class, allowing you to use it as if it were a function itself.
The second use case adds a new product to the database. It receives an object of type product that represents the item to be inserted. It calls the insert product function from the repository to perform the insertion operation. The result is wrapped inside a result Boolean object to indicate whether the operation succeeded or failed. If successful, it returns result.success is true. If it fails or an exception occurs, it returns result.failure.
Here is the class that inherits and implements all the functions of the product interface. First, it must receive either an API for working with an external server or a DAO for working with a local database. Then, we define each use case separately, and for each one, we call a corresponding DAO function, for example, fetching all products, getting a product by its ID, or inserting a new one. Defining the DAO itself is very simple when working with Room database. All you need to do is define an interface called, for example, Product DAO, and place the DAO annotation above it. Inside, you add the data operations you need as separate functions, each with its own annotation. To insert a product, we use a function that takes a product object and returns the ID of the inserted row. To fetch all products, we use a function with a select all query that returns a list of products. To get a single product, we use a function that receives an ID and returns that specific product. Finally, there is a delete function to remove a product from the table. A small note: all these functions are marked as suspend so that they execute in the background. This is important because data operations fetching or updating may take some time, and using suspend prevents them from slowing down the user interface.
Now, let's take a look at the View Model class and the clean architecture structure. The first thing we notice is that it receives use cases as parameters instead of creating the repository directly inside it, as happens in the MVVM pattern. In this view model, two use cases are executed, fetching products and inserting a new product. The class contains variables of type live data and state flow to track data updates and the state of insert operations. This defines a private _products variable that can be modified only inside the view model, and a public products variable that the UI can observe for updates but cannot change. And this pair is used to hold any error messages that occur during operations, allowing the UI to display them without directly modifying the data inside the view model. Then their load products function, the use case for fetching products, is executed inside view model scope.launch, ensuring the process runs in the background without affecting the user interface. Once completed, the product list is updated, or an error message is displayed if an exception occurs. In the insert product function, the use case for adding a product is called. The state first changes to loading, then the operation runs, and the result is returned inside a UI state object. If successful, a success message is displayed; otherwise, an appropriate error message appears.
Now, let's move on to the main screen, where we bring all these components together and use them in sequence. First, we call the database factory class to specify the database we want to work with and obtain the DAO from it. Let's take a look at how this works. In this code, an object is created to build the database using Room. The database factory object follows the singleton pattern, meaning only one instance of the database is created throughout the app's lifetime. The variable instance holds the created database instance. The annotation volatile keyword ensures that all threads always see the most up-to-date version of this variable. Inside the getDatabase function, the code first checks whether an instance already exists. If it does, it returns it directly. If not, the database is created inside a synchronized block to make sure only one thread performs the creation. Finally, the new instance is stored in instance and returned for future use.
Next, we can create an instance of product repository implantation and pass the DAO to it, allowing it to interact with the database. Then, we create the two use cases, insert product use case and get products use case, and pass the repository to each of them so they can use it for their respective operations. After that, we create a product view model and provide it with both use cases. This allows the view model to act as the mediator between the user interface and the internal business logic of the app. Finally, inside set content, we create a sample list of products that includes each product's name, price, and image. These products are then added to the database by calling insert product _ for each one. This process inserts the data into the database so that it can later be displayed on the screen.
Now, let's move on to the part that displays the products on the screen, using the product screen function. This function receives the view model, which handles both data retrieval and database interaction. At the beginning of this function, we observe the values from the live data inside the view model using observe as state. One observes the list of products. The other observes any potential errors. Then, we use launched effect to call load products once when the screen first appears, in order to fetch data from the database or the network. Next, A when statement is used to determine what to show to the user based on the current state. If there is an error message, it is displayed on the screen. If the product list is empty, a message appears indicating that no products are available. If data is available, it is displayed in a two-column grid using lazy vertical grid, which arranges the items neatly in a 2x2 layout. Each item is passed to the product card composable function, which handles the design and presentation of a single product card. Inside, we use card to display the product in a clean, elegant style that includes the product image using image, the product name and price in a clear format, an Add to Cart button that will later enable adding the product to the shopping cart.
Now Gene encourages you to add the functions needed to make the Add to Cart button work.
Thus, the cycle between displaying data on the UI and retrieving it from the view model is completed, a practical demonstration of how clean architecture connects all layers seamlessly. I noticed that we define all types of variables and constants in these lessons, but we never define ourselves.
That's true. Let's fix this bug. I am No Name.
And I am Coda, the programming duo who loves to simplify complex concepts.
And if there are any concepts or topics you want us to explain in upcoming episodes, write them for us in the comments.
And you can write your comment in your language, whether English, Arabic, or others. If today's episode helped you even a little, then hit like, leave a comment, and let us know you're learning. Next time,
We will level up.